Hey there. So, in this lesson, we're going to talk about the rate of change. What is the rate of change? Well, the rate of change is the speed at which a variable changes over a specific period. In short, it's basically the change in the y-axis over the change in x-axis. Let me scroll down here. So, this is the y-axis. This is the dependent variable. The dependent variable is often the y-axis over the independent variable, which is often the x-axis. And most problems you'll probably get are with time, like distance and time. And time, I can say 90% of the time, 90% of the time is often expressed in the x-axis because time is independent. Nothing can stop time. And you may want to remember that in the future. Okay. And the average rate of change, there's a calculation for it. There's the average rate, or you can call it the slope. If you remember rise over run, the average rate of change and slope are terms that are used interchangeably. So if I say slope, I really mean rate of change, and if I say rate of change, I really mean slope. So you may want to remember that. And here's the equation. It's always the second point. This is the second point minus the first point. Also, whenever we read a graph, we always read a graph from left to right. Just how you would read a book, you read the letters from left to right. So from here to here, always in this direction. Let me just do that. Always in that direction. That's how you read graphs. Okay, so let's get down to it. Let's calculate the rate of change. So in here we have a graph with 2 points. So this is the y-axis, the height, and again, I know it's the I know the time is the x-axis because time is always expressed in the x-axis and like for every graph. And here is the y-axis, the height of the plane. And here's the second point. This is the second point, and this is the first point. As you can see here, you have your equation. We have your y2. This is your y2, and this is your y1. Which you have here, y2 minus y1, and over here is x2 or x1. So this is x2 over x1. Second point over the top, the second point over the second point is always ahead of the first point. And you have here, when you calculate it, you will have here, well, 600 over 4 minutes, or essentially negative 150 meters per minute. Now, how do I know it's meters per minute? I know that by looking at the units for the y-axis right here and the x-axis. I look at the units. Here is meters and here is minutes. So essentially it is meters over minutes. Simply because if you look at this formula, like height is expressed in meters and time in this case is expressed in minutes. So you either see it like that, or you may see it like meters and then slash minutes. So you may either see either form like this, or you may see it like that. People often do this because they just save space when they're writing things. Okay, so that's the first one. Here is another example for the rental of a vehicle rental cost. And again, this is your first point and this is your second point. And I'm gonna write that on here. This is point 2 and this is point 1. And again, we have point 2, the y, which is here, 700. 700 minus 400, so 700 here minus 400 here. And then essentially 400 minus 200, because this is the second point and the first point. So you have it here, and then eventually get $1.50, and that is in, yeah. So it's basically dollars. Those are the dollars per kilometer. Those are the units, and I know simply because if you look at the y-axis right here, this is in dollars, and this is in kilometers. So this is in dollars over kilometers. Those are the units. With money, it's different because you put the dollar sign ahead of the number. But in most cases, it would be behind. Like in most cases, it would be behind the number. Like for instance, 1 kilometer per hour. But if for money, it's often expressed like $1 per, I don't know, kilometer for money. So money is a sort of a different case that is expressed a little bit differently. But 90% of the time, it'll be expressed like this, like kilometers over hours. Okay, here's just a summary graph to see what type of rate of change there is. So if you have the first difference is zero. When I say the first difference, what they really mean is assuming that the bottom is constant, like like 200, 400, it's changing constantly. Is This is the first difference, essentially, in short. The basically change in the y-axis. The change in the y-axis is essentially the first difference. So if the first difference, the change in the y2 minus y1, if that's zero, it would look like this. The graph will look like a straight line. And you say the rate of change, and that's important to say the rate of change, not the dependent variable, but the rate of change is zero. For a constant rate of change, so the first difference are equal. So let's say you have, I don't know, 2, 4, 6, 8, or 2, 4, 6. For let's say that's for your y, and then your x could be just like 1, 2, 3, something along those lines. And you get the first difference, which would be 4 minus 2, which equals 2. And over here is 6 minus 4, which is also 2. So you notice that these numbers are constant. Therefore, you see, therefore the rate of change is constant. And notice that I'm getting these numbers from the y. I don't only use the x because the x is also considered constant, like 1, 2, 3. We don't really need that for the first difference. So you don't need this so you don't need this for the first difference, really. You just need the y's. And here is a good example. In this case, they are actually finding the rate of change because this formula is the rate of change, but the first difference, all you need is the top value. That's all you need. So in this case, we have the speed and the reaction time, and if you get the rate of change for each one of them, is all the same. So therefore, I know that the rate of change is constant, and it's also, in this case, when you look at the graph, it's increasing. Not the rate of change is not increasing, but the reaction distance is increasing, not the rate of change. The rate of change is constant. So the rate of change is constant right here, but the reaction distance is increasing, as you can see from this graph. Bear in mind, uh, if you get the rate of change between these 2 points, will be the exact same value if you get the rate of change between this point and the last point. It doesn't make a difference. So for example, let's say I grab this point and the first point and the last point. So I'm gonna do the rate of change. So let's say I'm gonna use m because m is often expressed. The slope and the rate of change are basically the same thing. So let's say so that one here, I'm just gonna calculate it. It's gonna be let's do 10 minus 0. So this point here, and then the first point here. So it doesn't matter. You all you need is 2 points. It doesn't matter which 2 points you use. I'm just choosing those two last points. And over here is 50 minus 0, and over here is will be essentially be 10 over 50, and that will eventually equal 0.2. So all you need is 2 points, and you can find the rate of change with just 2 points. And it doesn't matter which 2 points you use. So if I use this point and the first point, you will still get 0.2. And you know what? I'm gonna prove it to you right here, really quickly. Do the same thing. Let's just use this point here and the first point. So let's say 4 minus 0 and yeah, no, no, yeah, 4 minus 0 and 20 minus 0. If you pop that in the calculator, again, you'll get 0 0.2. 0 0.2. There we go. So that's that. Here's an increasing rate of change. So this is a curve. You do not know if it's quadratic or exponential, but you just know it's changing. You know it's a curve. So the first difference is changing, and it will look like a curve. And you will see that. Here's a good example. This is a changing. This is a changing rate. So it's actually like basically increasing here. It's like basically the rate of change is constant because it's almost linear, and then sort of like decreasing in the rate of change over here. And again, here's a table of first differences. And on a quiz test or quiz, I'm most likely going to be testing you on this. So you know how to get the first differences. That's important because that's very testable. And that's it. That's all I need wanted to talk to you about.